Okay, so these are some of the very best ones I think ever. Okay, so what we've got to do, we're going to use two different rules here. Okay, this is a current carrying wire, and so the first thing we got to do is we got to figure out that the magnetic field on this side of the wire, due to this current, is actually out of the page. Okay, and that's because I stick my thumb in the direction of that current, which is down the page. I wrap it around that wire, and on the right side, it's out of the page. So we definitely have a magnetic field out of the page. Now, if the current is decreasing, we are losing out of the page flux, right? And if we lose out of the page flux, we replace it. So therefore, the current in this loop is going to go anti-clockwise to replace that flux. So let's do that again. There was a lot of things that we did there, right? First thing is that this current creates a magnetic field. That magnetic field on the left side is into the page. On the right side, it's out of the page because it wraps around that wire, makes little circles clockwise as seen from above. So here it's out of the page. If I drew it, if I were to be so crass as to write on my computer screen, I'd be writing a bunch of dots here. Since the current is decreasing, we are losing flux out of the page. If you lose it, you replace it. So you replace it by going anti-clockwise. All right, let's look at this guy here. The current is increasing. Well, above that wire, the magnetic field would be out of this page, right? It's out of the world. It's out of this page, right? So the current is increasing, so we are gaining flux out of the page. So if we gain flux, we oppose that by going clockwise, which would be into that page, right? Right-hand rules. Okay. Now, the inner and outer loop, these things work exactly the same. So let's just figure this out, right? The outer loop, the current is increasing. So due to the outer loop, the one with the arrow, okay, the outer loop is creating flux into the page all the way inside of this thing, okay? So there's a bunch of X's inside, and outside there's some scattered dots, as many dots as X's, right? Okay, but they're scattered way out there. But definitely there's a bunch of dots. What would I say dots? X's. There are a bunch of X's inside here. Into the page is X, right? Okay. And we are gaining into the page flux, right? And so what we do is if we gain into the page flux, we create out of the page flux, anti-clockwise. Okay. Here in this guy here, the inner loop is decreasing, right? So the inner loop is creating flux out of the page, okay? And we are losing flux out of the page because it's decreasing. So therefore, the outer loop is going to go create flux out of the page to replace it. Oh, so crazy. Okay, having a hard time with scrolling here, just basic scrolling. Okay, so above this wire, the magnetic field will be out of the page. The current is decreasing, so we are losing flux out of the page. If we lose flux out of the page, then we replace it by going anti-clockwise, which creates flux out of the page. On this one, the current's going down, so therefore the magnetic field is into the page on the left side of the wire. Okay, so it's into the page there. It's a bunch of X's, right? We are gaining it because the current is increasing, right? So we are gaining flux into the page. If you gain flux into the page, you react by going out of the page.
You are in the school. Can you please report to the main office? Lucas Crop, please report.
Lucas Crop, baby. You're immortalized in my video. Okay, so here we go. So now we got the inner loop here. The inner loop's creating flux out of the page. Okay, and if we gain flux out of the page, the outer loop's going to react by creating flux into the page. Okay? Doesn't matter whether it's inner or outer, these all work the same. Okay, so here, this outer loop is creating flux out of the page. Yeah? But it's decreasing, right? So we are losing flux out of the page. So the inner loop will replace that flux by creating flux out of the page. Let's do one more row here. All right, so the current is flowing to the left, and so the magnetic field above the wire is into the page. Below, it's out of the page, but above the wire, it's into the page. It's decreasing, and so we're losing flux into the page. If we lose it, we replace it. So therefore, we go clockwise to create flux into the page. This guy is creating flux out of the page on that side, into the page on the right, out of the page on the left. we've got out of the page, it's increasing, so we are gaining flux out of the page in this, where this loop is, right? If we gain flux out of the page, we oppose it by creating flux into the page. Okay, so let's see the outer loop. The outer loop is creating flux into the page. So I use my right-hand rule. It's creating flux into the page, a bunch of X's inside there, right? We are losing flux into the page, and so the inner loop reacts by creating flux into the page. Therefore, it's clockwise. Okay, and then the last one here. Current in the inner loop increases. So the inner loop is creating flux into the page, yeah? Okay? And we are gaining flux into the page. If we gain flux into the page, the reaction is to create flux out of the page. So therefore the answer is anti-clockwise.